Well, hello everybody. Welcome into Great Atmosphere here on January 23rd of 2024. Just wanted to get started today by looking at the last 72 hours of precipitation that has fallen over the contiguous U.S. I'm sure many of you have heard about the flooding that's actually occurred over the past day or so in the far southern California regions in San Diego and that general region down there in California. Ultimately, it was not necessarily the amount of rain, it was the amount of rain and the rate in which that it fell which created such a panic and a stir there. Ultimately, the San Diego area does not get a lot of rain in general throughout the year. We are currently in its wet season, as it were. Normally during the mid-spring to early fall, very little rain falls in Southern California at all. That's what attributes it to its famously great weather. In the winter time, though, that's when it usually gets its rain, and unfortunately for them, they were caught up in a little bit of an interesting situation where we had ultimately the North Pacific jet coming in like this, and the primary crux of the jet was actually consolidated down here in the southern tier of California. And if we've drawn our jets before, where if it looks like this, and the apex of the jet is here, this left exit region is where enhanced convection and lift occurs. And assuming that there's enough moisture in place, and there certainly was due to the North Pacific jet being in an extension right now, that pretty much was the ultimate root cause of there being quite a bit of flooding in the Southern California tier, along with upslope flow, isotropic lift. There was a lot of things that went up into this system, and ultimately caught a lot of people off guard. And the soil that's in California, we could take a look at the precipitation graph, and this is going back all the way until this time last year. So you see the brown for San Diego International here is what is their normal amount. So they're already well over. The ground is relatively saturated on an annual basis here. And they got about 2.5 inches of rain already. So on a normal basis, when do we see 2.5 inches typically? Usually it takes until mid-February until we gradually get that amount, and we got it within the course of a couple of days there. And additionally, it's a very arid climate, you know, so naturally the soil is going to be a little bit more impervious and unable to absorb a lot of moisture if it gets it. If it gets it all in one amount. That's why you see in the southwest tier of the U.S. a lot of land and mudslides and big floods. You saw Burning Man earlier, I think it was last year, was completely flooded with mud because of the amount of rain that came in there all at once. It's just not an area that's used to getting a lot of rain, and that's the end result. So this is currently looking at our total precipitation ranks by climate district, all the way dating back to 1893. If you have greens, that means that it's been a wetter than average year, and it'll rank in terms of precipitation amounts, how it compares. And then anything lower, whites will be your average year, and browns will be more dry. So as you can see, it's been relatively dry in the far southwest region, specifically, and this is over the course of the past 3 months, so since the beginning of meteorological winter. So it's been relatively dry in the far southwest U.S., and additionally we have currently a good amount of drought in the deep south in Louisiana, Arkansas, Mississippi, and western Tennessee, also in Big Sky in Montana, and the Jackson Hole region of Wyoming and western North Dakota. Those are definitely our drier regions. But in the Central Plains, we had quite a bit of snowfall, and that's contributed very well to getting rid of the drought there. And then along the northern half of the eastern seaboard, all the way from the Piedmont of North Carolina all the way up and into the coast of Maine, these are some of the wettest times. This has been one of the most precipitative winters that the areas have had in over 100 years in some respects. Some the most, if you include eastern PA, all of Jersey, Delaware, the Chesapeake Bay region in general. This has been a very, very wet time in its history. You can take a look at the drought monitor, just kind of see where everyone stands, and specifically in that lower Mississippi River Valley region, they are in extreme drought down there. In addition to Iowa and southeastern Nebraska, New Mexico and Arizona, and of course California, as we've seen, they've been inundated with atmospheric rivers. and snowpack, so their drought is completely gone, which is a great thing for them, obviously. They've been enduring drought for the better part of a decade. Not the case anymore with our current climatological look, but that is currently where we're looking at from the drought monitor perspective. Taking a look at our current U.S. radar, we see that we have our main system, our main unsettled warm sector, kind of making its way through the through the U.S. at the moment on the eastern seaboard. What we have here is we have our polar jet, which is dipping all the way down around the mountain west and back up and around like so. And we have high pressure that is ultimately blocking to the far southeast into the Atlantic Ocean over the Gulf Stream. And all that high pressure is doing is ultimately advecting as much warm air and as much moisture as it possibly can, and interacting with high pressure that is sitting over the northern plains and the Canadian prairie, which is funneling in cold air behind it. Ultimately, it's going to start developing miniature panhandle lows. They're going to kind of make their way in the form of little shortwave troughs as we move forward into the week. That'll cause our disturbance. But these are two very significant high pressure systems, and the jet max ultimately is about right in this region, which is precipitating most of the icing that we're seeing across the Midwest. Chicago, I do not, of all days, to be at the Chicago O'Hare Midway airports, this is not the day. Or yesterday was probably worse, but today is definitely not it either. Icing, fog, rain, it's not great in that particular region. I believe there was a 6-hour ground stop in O'Hare yesterday, and I believe there's already a quite significant delay there. Not a great experience in the Midwest today. But it's the wet. The wet forecast is definitely already verifying. It's more scattered today, which is what we anticipated. We definitely anticipate much more of a broad rain shield to come in over the course of the next few days as we move forward in time. So taking a look at our all hazards scale here, we have our winter weather advisory and our floods and our flood advisories. These are flash flood warnings, I believe, or are they just regular flood warnings? Flood watches, okay. Flood watches in the deep south, those will probably be upgraded into flood warnings as we move forward in time. Then we have our winter weather advisories as the warm air overruns the cold and interacts with the Great Lakes. That's generally going to be a little bit more of a lake effect event as well. But the main thing that no one seems to be wanting to talk about is this big old gray mass right in the middle of the country. That is fog, and this extends because it extends probably around this general region as well. Those advisories extend there, but winter weather advisories trump fog advisories on this map. So it's a pretty dense fog deck that's across pretty much it's bisecting the entire country today. And I thought it was pretty interesting because you definitely can see it here on the map. You see stratocumulus going across the majority of the southeast with some scattered showers over the Carolinas and a majority of our rain coming across the Texarkana, Oklahoma region. But you see that this isn't snow. That would be a pretty significant snowpack. Snow is more represented by what you see here in the Sierra Nevada and the Rockies. That is a very thick layer of surface level fog that has made its way into pretty much all of Kansas, pretty much right on that Colorado border. That's quite interesting how that worked out. But Kansas is completely covered, and all points pretty much from that longitudinal meridian right there and due east is pretty much completely interlocked with fog. And I was wanting to kind of explain why that happens, if I could, real quick. So what we had here is essentially there's snow on the majority of those surfaces in the Midwest, and if you were in a room and the room was filled with ice cubes, right? Ultimately, the closer you are to those ice cubes in the room, the colder that the temperature is going to be, right? Because if you go over here, it's going to be warmer than it is if you were standing right next to the ice cubes. Well, the same thing applies to the ground and snow. So in the event of there being snow on the ground, so we'll have that dictated by these little right here, that makes the area that is specifically right over the ground, also called the boundary layer of the atmosphere, like up to maybe 10 meters in the sky, colder than the air that is aloft. And the air could be cold up here as well, but it won't be as cold as literal ice being on the ground. So this air is generally colder than it would be up here. So we have warmer air aloft, colder air at the surface. So when we have colder air, the ambient air in this general region, since it's colder, it can't hold as much moisture, just because when you have colder air, the air is much more dense, and there's not a lot of space for water molecules to be able to get in there. So if it's like really, really dense, these are my representations of air molecules, right? So they're really dense close together, and up here they're more spread out. It's still cold, but it's not as cold. There's a lot more space in between these molecules in the warmer air, right, than there is down here. So ultimately, the atmosphere cannot hold as much water at the surface level parts of the atmosphere than it can there. So what does it do? Well, we have dry air coming in, which we represented from the high pressure that was building behind it, and dry air likes to evaporate snow, or evaporate water in general as it comes through. So we have warm air advection that's coming in and melting the snow, and ultimately evaporating it. Okay, so I had to redraw my drawing here, so sorry about that. So we have the snow, and then we have dry air that's ultimately evaporating, right? The snow, melting the snow, and ultimately, due to the warm air that it's currently experiencing across the majority of the country, as it evaporates, it'll have to condensate in that area right above it, just because it's so cold immediately, right? So instead of it, if there wasn't snow on the ground, then it would just evaporate up into the sky and maybe get a low cloud deck, and that's no big deal. But it's so cold at the surface layer of the atmosphere, ultimately it's going to condensate and make a cloud right as it evaporates, and that's where we get our fog. Draw fog. That's fog. And that's essentially what's going on across the entirety of the country right now. In this particular region, we have our warm, moist air, which is coming along this way, and then it's being interacted with in the cold, but the cold is not as strong as the warm air advection aloft. And we have cold air at the surface, and when that interacts, the cloud layer essentially gets built right on top of the ground. So, kind of cool phenomenon. Not a lot of people talk about fog. It's not a lot of doctoral theses get written about it, unfortunately. But it's very impactful, and there are some very dangerous roadways. One of the most costly and deadliest car accidents of 2023 was actually in the New Orleans area next to Lake Pontchartrain, when visibility for fog went down to less than a quarter of a mile, and ultimately 73 cars along the interstate got piled up on the interstate, and ultimately killing a few people. When fog is certainly one of those things that you don't think about as something that is to be concerned with, but it's certainly very impactful, and we're seeing it on a very grand and large scale today. So it's definitely something to be cognizant of. So as we've been tracking over the past couple of days, we've been tracking the North Pacific Jet, and we see that it's currently bisecting California at the moment. So we see it kind of splitting off in this general region, right? And that's bringing a lot of moisture into the west coast of the United States. And we can see that that extension is going to last here for a little bit. It'll bring more unsettled weather. We have our high that, or jet stream, or I'll say our jet trough, I will say, is being formed right in the Mountain West, and it'll go all the way down here. This is up in the 300 millibar level, so it's not the most accurate depiction. But we have our generalized Gulf Stream making its way through and creating a much more moist environment in the southeast, and the split is occurring over there in California. But ultimately, we're going to go through, actually this, yeah, there we go. So that's what it's looking like. I was all the way, apologies for that, I was looking all the way over into next week. But ultimately, we're expecting a little bit more of a jet extension over the next couple of days, so it'll slowly and gradually make its way back over to the U.S. as we move forward in time. And you can see that as long as, and these are pretty high winds as well. I believe that these winds in the center, this maximum, is close to 200 miles an hour up in the 300 hectopascal region of the atmosphere. And that's a lot of forcing to deal with. And if that gets over into our general region in the west, that can ultimately impact us quite a bit in terms of long-term weekly weather forecasts that we would expect. Kind of destabilize the atmosphere. But until then, and what I was going to explain earlier is that later this week it's going to be going into a retraction. So most of that jet maximum is going to be over off the coast of Japan. And whenever there's something like that, typically the rebound effect hits us about a week later whenever these things occur. So if we see a retraction this week, that means that the effects of that retraction are going to hit us in the United States next week. And when that occurs, it usually results in more of a geostrophic flow over the eastern part of the U.S., which is a stabilizing type of weather event. So we would probably expect to see mainly sunny skies next week, which is antithetical to what we're experiencing this week, which is pretty much going to be dominated by a mild rain. Another thing to keep an eye on is our sudden stratospheric warming event that has been dominated the first half of the month of January of 24. That currently is starting to die down a little bit, and our polar vortex is once again beginning to strengthen. So move forward in time as we go to the week, and you can see that donut, it's cutting out on me, apologies about that. So that donut, as it goes further and further into next week, gets more and more organized and even on all sides of the Arctic. And when that happens, it just means that it has successfully trapped all of the cold air. And this was not the case. And you see how organized this is. You see a lot of that cold air is being preserved up in the upper reaches of Canada, Alaska, Siberia, and anywhere that's not generally over water. And so essentially what that polar vortex is doing is it's trapping a lot of the cold air, and that means that all the warm air that would otherwise be getting kind of twisted up and in here, and you see a little bit from the Atlantic stream right here, that is ultimately not going to be as impactful up in the Arctic, and therefore it's going to be trapped down where we are in the mid-latitudes. So ultimately this is a big sign of a warming trend. Sudden stratospheric events in the polar vortex are generally measured by the Arctic Oscillation and the North Atlantic Oscillation teleconnections. And you can see that whenever the NAO specifically goes positive, which you can see from the index is currently at about a 2 on the rating, we would expect it to kind of have a very strong polar vortex, and the cold air gets trapped up into the Arctic, and the warm, moist air gets pushed down into the mid-latitudes where we are. That ultimately is playing out currently for the next week or so. Now, the ensembles do predict it coming down to a more neutral stance going into the beginning of February, which we'll definitely talk about. But at least for our weather here in the next 10 days, we would expect, as the NAO is positive and the polar vortex is strengthening again, we can expect more mild weather as we move forward into February. Now, the big story coming out of today and tomorrow and Thursday will be the rains, and ultimately the rain is going to be a major player for the Deep South in Louisiana, Mississippi, eastern Texas, particularly the Houston region. We can look at day one that this area, and I believe it's Waco, Plano, the greater Houston metro, and parts east. I can't remember if College Station's in that general direction. I think it is. Texarkana, Shreveport, that particular region of Louisiana, far down into Pine Bluff, Arkansas. That's going to be areas where at least a 40% chance of a flash flood guidance needing to be introduced within 25 miles of any point. That's quite considerable, and those particular areas could, in localized areas, get potentially 7 to 10 inches of rain over the course of the next 36 hours for an area that certainly needs it. As we looked before at the drought, that is almost right on spot in terms of who needs it the most. But the side effect of not having a lot of this, not having a lot of previous rain, is that the soil is pretty impervious, and it will be more susceptible to flash flooding. And the reason that we're getting this flash flooding is due to this incredible moisture transport. This is the 925 to 850 millibar layer moisture transport map diagnosed by the SPC. And you can see anywhere denoted in this green is essentially areas where we would expect if rain were to fall, it would fall in buckets, because the precipitation, the precipitative water amounts in those particular regions is quite high, and the atmosphere holds in due to that warm air being advected in so strongly. It can transport a lot of moisture, and ultimately it can dump a lot of moisture as it gets further up into the mid-latitudes or up in the upper latitudes. So ultimately that is what is to be expected over the next couple of days. Not necessarily the biggest severe threat in the world. There's only it's only a marginal risk for areas from, I believe, Panama City Beach, Apalachicola, Florida, through the Mobile Bay, into the southern tier of the Mississippi Panhandle on the Mississippi Gulf Coast, and the Louisiana coast and the New Orleans metro region. Those areas can see a marginal risk of severe thunderstorms going into day 3. So this would be Thursday. And then day 1, same deal, except more of it's a Texas thing. I think this threat is actually probably a little bit more pronounced in Texas. There does seem to be a little bit more instability that's in place over the Houston area. Probably one or two soft spots that could get a tornado or two out of that. Due to this is generally the time of year that actually the southern plains is susceptible to very strong tornadoes. Weirdly enough, it sounds, but some of the strongest tornadoes have actually come in January, February, some up to the EF3, EF5 range, particularly due to blocking patterns like this, where we just get an incredible shear. A high pressure sits off to the coast, off the Gulf Coast, and ultimately just brings in a lot of warm air that tries to mix in with a cold environment. And that is and if there's enough low-level shear associated with that, we can get some pretty big twisters out of that. So definitely something to watch. SPC only has a marginal outlook for it. We can see maybe what they're looking at here. Vigorous convection across South Texas, which evolves into an MCS. Severe threat could develop in the overnight hours. That's particularly bad, obviously. Don't want any tornadoes in the overnight. Not really talking about mid-level upper shortwave troughs. We discussed the shortwaves. That's going to be upper level flow exists ahead of the low latitude southern stream trough. Yeah, that make all the ingredients are there. It's just not a lot there. Not a very strong trough in that of itself. Not a lot of forcing associated with it. If that trough was instead, you see how if the pen comes up. So we see if this is generally the trough pattern as we go forward in time. If this were more of like a meridional, like this, and all that forcing just gets pushed up immediately, like in a 90-degree angle, that's where we would see a lot more concern for severe weather. But fortunately, it's more of a positively tilted trough, so therefore we do not see that so much in that respect. So as we move forward, we're going to compare our two flagship models, the GFS on the left and our Euro on the right. As we move forward in time, it's going to be wet in general. As we go forward, this is Wednesday at noon. Generally speaking, the rain shield definitely becomes more pronounced, and the majority of the precipitation for the Deep South will fall Wednesday into Thursday, and it will come in multiple rounds as well. A little bit more in a scattered sense for the GFS. GFS has always been more bullish and more of that convective mode than Euro has. Euro has definitely said more of a rain shield event, less of a shortwave trough upset in the pattern. GFS goes the other way, so it'll be interesting to see which one pans out. The SPC is banking on the Euro, it seems. And we move forward, and you can see this goes all the way out. We have generalized equal chances for rain all across the southeast until we get to Sunday. That's when that final shortwave trough will seem to get enough of a forcing behind it to start to cut itself off, bring enough dry air in behind it so it gets down to the coast, ultimately works to set this big ball of energy up and from the panhandle of Oklahoma, and make its way into the mid-Ohio Valley and start making its way up into the northeast. And ultimately that will give way to cold and dry air from the Canadian prairie that's been building up. It won't be as cold, it won't be Arctic air, as that polar vortex will be pretty solid by this point. It'll be more of a intermediate polar cold, more seasonal, I'll say. but it will still be colder than what it will be, because the temperatures that we're expecting later on this week, I know in the southeast, some areas will be getting up to 70, 75. That's pretty ridiculous and quite a departure from last week, which was some areas a 50 to 60 degree difference based off the current day of the week compared to last. So really, really interesting stuff and quite a dynamic environment as we move forward next week. And you can see the end result of that jet retraction. The North Pacific jet has moved at this point, or due to it being retracting all of this week. And at this point, let's go back to like Wednesday. This is kind of the peak of the retraction event. It'll start to become more of an extension again as we move forward, but we don't see the results of that until about a week after the fact that it's happened. So at least here in the southeast, at least. Different story for the west coast. But in the east, it takes about a week for that teleconnection to make its way over here. And ultimately, the results of last week's jet retraction is going to make its way over to us. And next week actually turns out to be quite dry. Get some little lake effect snow perhaps in the upstate of New York and New England in general. But ultimately, it'll be nice, dry, and probably mild weather. Mild in comparison to seasonal climatology, not necessarily the crazy zany temperatures we've experienced on both ends of the spectrum over the past couple of days. And we can take a look at the precip totals. So this is generally what they're expecting. Pretty broad rain across the entirety of the southeast, and we'll take it all the way until the end of the period on midnight on Monday. We can see those areas: Louisiana, Houston. We're looking at 4 or 5. Maybe even 6 inches in some spots along the Florida Gulf Coast, along the Gulf Coast in general, and in the problem areas of the North Carolina rainforests. That's going to it's going to be quite problematic, and a lot of rain gets actually up here into the into the High River Valley, and this might actually be more of a snow event due to the lake effect. But across the board, across the eastern seaboard, we can definitely expect over 1.5 inches all the way up to about 5 inches in some respects, based off of wherever those rain bands just decide to train over. So definitely will be definitely a wet pattern ahead. And as far as looking at the instability and why I'm not too concerned, I know here in Charlotte, and a lot of the local Mets were concerned about maybe a Thursday severe event. I'm just not seeing it. Lapse rate is one of those things that, it needs to be in place at an elevated level in order for there to be enough convective available potential energy and to kind of propagate. And I'm just not seeing the lapse rate. Certainly see the lapse rate here in Texas as you go through the week, but ultimately not a lot to write home about in the rest of the southeast, which kind of leads me to believe that it'll be, at least, and this is the NAM that goes all the way only until Friday. So I don't have a lot of faith in the Thursday storm. Definitely going to have to take a look at Saturday. That definitely, as that panhandle low starts to form in on itself, we'll see how deep of a trough it wants to create as it goes forward into the Ohio River Valley. Ultimately, if that low decides to form here, actually I don't want to take a sounding. There we go. I gotta go back, sorry. And we're doing a sounding. Drawing, please. There we go. Okay, so if the low forms here, we're going to assume that it's going to form in that general region. And it goes like a little dip, and then it goes into the Chicago region. Well, that's typically indicative of a more positively tilted trough, and we wouldn't expect to see a lot of convective instability across the southeast. But if that decides to go a little bit further south and then dig up into the same direction like so, well, you can see that that's a little bit more of a steep incline in terms of vorticity. And if the jet maximum just happens to be in this general region, well, that would lend itself to a more of a severe threat for Georgia and the Carolinas as we move forward into Saturday. But until then, I wouldn't anticipate any major severe threats. Of course, there's going to be 1 or 2 problem spots if a shortwave manages to form itself in the next few days. But ultimately, on a grander, more synoptic scale, it's not something that I would generally anticipate to see until we get more model guidance from the CAMs on Saturday. And then as far as what we're looking at going into next week, and we kind of alluded to this based off of our North Pacific jet extension versus retractions, we can go and we see our p-watts. This is like taking a big slice out of the atmosphere and seeing how many inches of water would be in every cubic meter of the atmosphere if you were to take a big slice out of it. And ultimately, we're seeing that that humidity in place all the way through Saturday, and then we see that low start to form. Big dry air starts to form over the southeast as we get into Monday, Tuesday, and that kind of stays as a result of that retraction that we talked about that affected us last week, or in this case, last week being this week. But then after that, we get the extension again, which we'll experience later this week, and obviously the end result of that extension will make its way to our, if this is not confusing enough for y'all, I should probably start using dates. But as we move forward into the beginning week of February, I guess that doesn't make sense because it's split next week. Second week of February, we would expect to be back into this wet pattern. Next week, we expect a dry pattern. This week, we're in a wet pattern. So that's kind of the area that we're kind of going in. Very spring-like, honestly, and that's very indicative of kind of where we are from the polar vortex point of view, with the polar vortex being all the way up in this particular region. I'll take you all the way to the heights here. Wind at 10 HPA. Yeah, so with the polar vortex being all the way up here, there's definitely... there will still be dynamic weather events, obviously, but it generally won't be a major Arctic interference that will be the main driver of it. It'll be mainly convectively driven and not thermodynamically. So until we can get until that polar vortex decides that it wants to act up again, that's going to be in order for us to get snow here in the southeast. Generally speaking, that polar vortex needs to act up. Not a lot of signs, at least in this particular guidance, that that's going to make its way and be the case. NAO definitely has us going a little bit more neutral, but we need this to go negative if we want to have any chance of getting enough cold air in the southeast for some of the wintry stuff. Definitely not. A lot of people are saying, "Oh no, it's the end of winter already," and the groundhog on February 2nd is going to say that we're screwed. I lay on the brakes there. Some of our most severe wintry events have occurred in February and March, and the beginning of both of those months have started out looking like as doom and gloom as this. But at least for the next 2 weeks, I wouldn't expect a major winter system in the southeast based off of that. So that is what we are looking at. I appreciate y'all tuning in. This is Great Atmosphere. My name is Zach. I appreciate you tuning in. I make videos like this every weekday, particularly pertaining to the southeast, but I'll obviously talk about how the surrounding synoptic weather patterns affect us in the southeast. But ultimately, I'd appreciate your subscription if you're interested, and I'll see you again tomorrow for another forecasting video. Take care.